In this investigation, we will continue using function notation, but we will start creating new functions by combining two or more previously defined functions using basic arithmetic. To explore this idea, let's consider the following context. Suppose two particles, particle A and particle B, begin moving in the same direction away from a wall. Particle B starts at the wall, but particle A starts a little ways away from the wall. And I have this shown here. Let's represent particle A and particle B's distance from the wall using segments. Now, particle A's distance from the wall is a function of t, and so is particle B's distance from the wall. So we can define functions A and B to represent particle A and B's distance from the wall in feet in terms of the number of seconds t since the particles started moving. Now, as t varies, notice how A of t and B of t vary. Both segments increase, but it looks like B of t is increasing faster than A of t. Now that we have defined functions A and B, we can actually use them to define new functions. For example, suppose we are curious about the particles' combined distance from the wall. So I'll represent this with a segment. So these two dashed segments, if you imagine gluing those together, represents the combined distance from the wall, or like combining particle A and particle B's distance from the wall. And this distance is a function of t, so we can actually define a new function c to represent the combined distance from the wall in feet. As t varies, c of t will increase accordingly. Notice that c of t is really just like combining a of t and b of t. So the function definition for c of t is actually c of t equals a of t plus b of t. Or we can use this formula to describe c of t. On the other hand, we might be interested in how much further particle A is from the wall than particle B. So let's remove the dash segments. So let's go backwards in time a little bit. And let's look at how much further particle A is away from the wall than particle B. If we imagine varying t, or letting t increase, then at first this distance is positive, and then the distance becomes negative, represented by the fact that this vector is pointing to the left. And this is because particle B becomes further away from the wall than particle A. Now, this distance is actually a function of t. So we'll let the function d represent how much further particle A is away from the wall than particle B in feet, in terms of t. So as t increases, d of t is first positive, and then d of t is negative. And d of t is really the difference between a of t and b of t. So we can actually define d of t as a of t minus b of t. So in this way, we can use the functions a and b to define new functions to model other relationships in the situation. And this is actually really useful. Notice that if we actually have function formulas for a and b, we can write function formulas for c and d. So recall that t represents the number of seconds since the particle started moving. A of t represents particle A's distance from the wall in feet. B of t represents particle B's distance from the wall in feet. And we actually have function formulas for a and b. So these two formulas right here are the actual function formulas for a and b. So a of t is equal to 2.5 plus t, and b of t is equal to 2t. We decided that since c of t represents the combined distance from the wall in feet, c of t was equal to a of t plus b of t. And since we have formulas for a of t was equal to 2.5 plus t, and b of t was equal to 2t, we can just substitute those expressions in, and if we simplify this, we end up with 2.5 plus 3t. So c of t is actually equal to 2.5 plus 3t. So using our formulas for a and b, we can actually write a function formula for c. Similarly, we decided d of t what's equal to a of t minus b of t, which is equal to 2.5 plus t minus 2t. And this will actually be equal to 2.5 minus t. So now we have a function formula for both c and d, just using our function formulas for a and b, and knowing how c and d relate to the functions a and b. In the rest of this investigation, we will explore other contexts where we can use two previously defined functions to define new functions to model relationships.